So this problem I'm going to attempt in two different ways. The first one is the direct method, and that ignores the first piece of information that's given to you about the sum of the first n positive integers. So this is really 1 plus 2 plus 3. That's what they mean by this. So I'll apply the direct method first. And so the question is, what is the sum of all the even integers from between 99 and 301? So I'll write those out: 100, 102, 104. And generally, as a habit, I write the first few and then the last few, just to kind of see the pattern. And we notice that each term is 2 apart. So this is a uniformly spaced sequence, or an arithmetic sequence. And here, the average is actually equal to the median. We don't really need the median part here, but the key thing is the average is related to the first and last term. It is the average of the first and last term. Again, I'm not going to go over why this is. That's part of the concept videos. But here, it would be 100 plus 300 over 2, which is half of 400, is 200. So that's the average. Now, the sum is equal to number of terms, and this is true for any sequence times average or any list of numbers. And I already know the average is 200. Now I need to count how many terms are there. And there's also an expression for that. Again, I'm not going to go over that. Is number of terms is last minus first over the spacing, meaning how far these terms are, plus 1. So in this case, the last is 300, first is 100, spacing is 2. They're all 2 apart, plus 1. So this is 200 over 2, which is 100 plus 1, 101. So that's the number of terms. So the sum is the average times the number of terms. 101 times 200, double that, that's 202. Append the 2 zeros. So the answer is 20,200. So that's the most direct way of doing this problem. Now, this particular problem, the way that the writers have written it, they obviously want you to use that information in the first sentence. And so I'm going to do it the way they are expecting you to do. You may choose not to do it that way, but I think it's good to know that, because there might be other problems where what we applied may not be applicable and you may have to use the information given. So the piece of information we're given is that the sum of the first n positive integers is given by this expression. So what that really means is if you need to add 1 plus 2 plus 3, here n is 3, you replace n with 3 in this expression, and you will see that that is indeed, this is 6, and you'll see if you add these terms, it's 6. So we have to use that information. So we're given, or we're asked to find the sum of 100, 102, 104, all the way to 300. Now they're all even, spaced apart 2. Now if I were to factor a 2, and I think this is sort of where you have to kind of play with this expression, meaning, you know, how did I notice that I have to factor a 2? Well, the idea is I want to relate it to sum of consecutive integers. And once I take out 2, then these become consecutive integers. And this would be 149 plus 150. Now I can apply this formula, although you have to be careful. This is from 50 to 150. So first I'm going to find the sum 1 through 150. And basically here n is 150. So 150 times 151 over 2. So, and I'm going to actually leave it like this. Hopefully it might simplify. I like to hold off these kind of computations. And so this is the sum from 1 through 150. We need 50 through 150. So what I'm going to do is to find the sum from 1 to 49. And that's the one you have to watch out, because it's 49 plus 50. This is the piece we need. And that would be replacing n with 49. So it's 49 times 50 over 2. So that's 49 times 25. Now, this sum here would be this first sum minus that, because I'm taking out the terms 1 through 49, and I'd be left with that. So our original sum, we still have the 2 outside, is the difference, 2 times the difference of that. So 75 times 151 minus 49 times 25. Okay, so I want to be a little bit lazy, so I'm going to factor a 25 because I see 25 times 3. So that's 3 times 151 minus 449. And I guess I'll have to do this computation. So that's actually 453 because 150 times 3 is 450. So 453 minus 49, which is 404. And 25 times 2 is 50. So the answer is 50 times 404. And that's, we should get the same answer. 5 times 4 is 2002. So that's 2020, and then we have the 0 from here. And we do indeed get 20,200. So this is really the method the writers are expecting you to apply in this problem. But as you can see, it's actually harder to do that. And in this case, it's faster to just apply this. And I've seen this in other GMAT problems too, where you have this option of doing it directly. So, you can choose either method, but to recap, the answer is choice B.